the next thing is we will calculate intensity of the wave. Intensity of the wave. Intensity of the wave. What do you mean by intensity? When sound energy is propagating through the medium, the sound energy is propagating to the medium in the form of oscillations. The average energy flowing through unit area, normal area. The area must be normal to this propagation in unit time. The average energy flowing through unit normal area per unit time is called intensity of the wave. That is, what is the unit watt per meter square is the unit of intensity of the wave. Okay. Let me find the expression for intensity. Look at this. In case of sound wave, the energy is in the form of both kinetic and potential. The maximum energy, let us say, half m a square omega square. This is same as our SHM energy equation, half m a square omega square divided by area of cross section into small interval of time dt. I can write the small interval of time dt. Now you multiply and divide by dx small, okay, dx. Okay. Now A into dx is nothing but volume of the small element. Okay. A into dx is the volume. Mass per unit volume is nothing but density. Mass per unit volume is density. Half rho a square omega square, and dx by dt is velocity of the wave. This dx by dt is the velocity of the wave. So the intensity of the sound wave is half rho a square omega square v square. So the intensity is directly proportional to square of the amplitude, square of the frequency, and depends on the velocity of the wave, and also depends on the density of the medium. This is the expression for intensity of the wave. Okay. So this is all about the intensity of the wave. Next we will go to another type of wave, that is transverse wave. Now what do you mean by transverse wave? Okay. As we know that any periodic variation is called wave. Depending on the direction of vibration of the particles of the medium, any progressive wave is the one without any reflection back, it travels. We can classify into two categories. If the particles of the medium vibrate in the direction of propagation like this, it is called longitudinal wave. If the particles vibrate perpendicular to direction of propagation, like where wave is traveling along x axis, the particles are vibrating along y axis, we call it as transverse wave. Okay. So now according to this definition, our sound is a longitudinal wave. Okay. Now we are going to discuss transverse wave, which is very important. let us say a string fixed at one end, a string is fixed at one end, you are holding with a tension T for other end. Okay. You are holding the string with tight T is tension in the string, okay, and give a small disturbance, like this. You can give a small disturbance. Okay. The disturbance travels along the string. After some time, we can find this pulse is here. Okay. So, here the disturbance is traveling along x direction, but particles of string vibrating along y direction. This type of wave is called transverse wave. So, now we know that velocity of any wave depends on the two factors, elastic factor and inertial factor. So, here tension is elastic factor, then what is the inertial factor? In air it is mass per unit volume. In case of transverse wave, it is linear density small m. Linear density. Linear density. What is linear density? Okay. Density is defined as mass per unit volume. Linear density is defined as the total mass of the string divided by total length. Total mass by total length is linear density. Okay. For a wire, mass per unit length is called linear density. Okay. Tension. Now, the velocity with which this transverse wave traveling along the string depends on tension and linear density. Okay. So, tension is elastic factor, linear density is inertial factor. How they are related? So, V depends on T and small m. Of course, we have different ways of deriving the relation between the physical quantities. Okay. The easiest way is let velocity is depends on tension to the power of x, linear density to the power of y. Okay. V is equal to T to the power of x and m to the power of y. By you applying dimension analysis, we can find V is equal to root of T by linear density. Okay. Velocity of a transverse wave V is equal to root of T by m. Or by using the knowledge of the circular motion, you can also derive the formula like this. Let us take this is a small part of this pulse, just amplify it. Let us take the small element of this, the pulse which is traveling along the string. Okay. Small element. Okay. This small element subtends an angle d theta. The small element subtends an angle d theta. R is the radius. The tension in the string always acts along the tangent. Okay. So, due to symmetry, you take one more element this side, okay, and tension will act this side. Okay. Let T is the tension in the string. So, now if I resolve this tension into two components. This is also d theta. It is d cos theta, and the component of tension acting towards center is T sin d theta. Okay. If I resolve the tension into two components, T cos d theta and T sin d theta. Similarly, from this side also. Similarly, this also can be there. So, what is the total force acting towards center? 2T sin theta. The total force acting towards center is 2 sin d theta. The total force acting towards center is 2T sin theta. Let us equate to this 2T sin theta to mv squared by r. According to F is equal to ma, F is equal to m into A is v squared by r. That is the centripetal force acting towards center. Now, for small angle, sin theta can be replaced by d theta. Then what is mass? Where m is mass of this total element, which is nothing but linear density. What is linear density? Mass per unit length multiplied by length of the total part is 2 r d theta. Okay. This is r d theta, this is r d theta by r into v square. So, if I cancel d theta and 2 here and r here, I will get the velocity of transverse wave v is equal to root of tension by linear density. The velocity of transverse wave v is equal to root of t by m. So, this is a very important formula. So, whenever a wave is travelling along a string, transverse wave, the velocity is root of t by m, which is nothing but root of elastic factor by inertial factor. So, in the same place, in case of sound wave, we have root of bulk modulus by density. Okay. So, in that place here now root of t by m. Okay. Now, once you know the velocity of transverse wave, then we will discuss the wave travelling along the string.